Hello class, this is Professor Gavoor. Um, we're going to start with this data set, and I'm going to change it actually to months. It's just some actual sales over a period of 10 months, 10 weeks, 10 years, it doesn't matter. And we're going to try to see if we can forecast using moving average, exponential smoothing, and linear regression. Okay. So let's take a look at this and see how we're going to do it. I'm going to copy the data set. I'm just going to leave the regular data set there. I'm going to go down here to the plus sign. I'm going to add another worksheet. I may add another couple worksheets. Let's call one of them data set 1 moving average. Let's call the other one data set 1 exponential smoothing. Exponential smoothing ES. And 3 data set 1 simple linear regression. Now, if you really get into this, you can play with data set number 2, which is the Dow Jones by year since the beginning, from 1915 to now. Probably you'd want to use, try to predict the closing Dow Jones each year using this column and as Y and this column as X. You can also try to predict the percent change every year, which would be also interesting. But if I'd want to predict this. So we're not going to do that. That's something you want to do. We're going to do it very simply. And what I'm going to first do is copy my data set, because I don't want to ruin the original data set in case I want to do something else with it if I end up manipulating it. And I'm going to copy it, paste it here. Let me make it bigger so you can see it, okay? And what's our first method that we're going to use? We're going to use, let's put another row in here. There we go. And the first thing we're going to use is moving average. Let's do a 3-month. I think that's what we tried to do in class today. So let's take this. I'll make it a maroon color. I'll make it bold, and I'll make it bigger. Okay, so it's very clear what we're trying to do. So I'm going to create a column for forecast. I'm going to create a column for absolute error. I'm going to create a column for absolute percent error. And I'll make the column a little wider so I don't have to wrap the text. And I'm going to do square error. So if I get my forecast and I get my absolute error, my square error, I can calculate everything I want to calculate here. Now, we're using a moving average. We can only forecast the next period with moving average. That's the same limitation as exponential smoothing. Linear regression, we can forecast as far into the future as we want. That's an advantage. The problem is you're committed to a linear model, which means the slope always means every month is going to go up by the same amount or down by the same amount. So we're doing a 3-month moving average. I cannot, and I'm using historical data. My next month is month 11, and I want to be able to get a forecast for that right here. So I can't forecast, so I'm going to use this previous data to see how my forecast is. I'm going to go down. The first month I can forecast is in month 4 because I have 3 months of history, and I'm just going to take the average of these 3 numbers, which if you look down here should be 435.666. So if I say this, I put it in here, I could add them up and divide by 3, but I choose to use the function for average in Excel, and I just click, highlight the range I want to calculate, the average of 3 numbers, C4 to C6. The columns are named after famous letters, and the rows are named after famous numbers. And I do that, and I get 435.666, but I really don't want, I only want 1 decimal place. And then I don't need to calculate it again. If I scroll this all the way down to 11, it will give me all my data. And there's no error. It's because the cells before it don't have anything in it. In fact, I might just highlight this, some sort of grayish color to show that because we don't have any history, we're not going to do that. I'll box all this in. I'm formatting while I'm talking at the same time. It's just the way I do things. You don't have to, you can format it all when you're done. Let's make the headers all bold. And I kind of use a light blue. I've been doing that for a long time. Just this is a typical table for me. All right, so now what's my absolute error? I can say equals ABS. ABS is, if you click on ABS here, it will open it up and tell me what the function actually does. Returns the absolute value of the number in the parentheses. And you can do calculations in the parentheses, which is exactly what we're going to do. We're going to take the actual minus the forecast. It doesn't matter. I could do forecast minus actual. Since I'm taking the absolute value, it doesn't matter. And if I bring this all the way down here, there's my errors. I'm off by, and I'm going to make it to 1 decimal place again. Okay? Now, what I can calculate, if I take the average of all these, and again down here it says it should be 28.9. Let's see if it is. Equals average of all of these. That is my mean absolute deviation. Okay? And I'm going to left justify that. Put boxes around it, and I'm going to highlight it since it's an answer I want to look at. Let's make it a light green color. Now, what's my absolute percent error? Well, it's going to be this number, the absolute error, divided by the actual. I want to find out how off I am from the actual. Oops, that didn't work very well. I do that, and then I have to put a division sign because I want to divide by that 450, which is in cell C7, and hit enter, and it gives me 0.031. Well, what's 0.031? And so I bring it all the way down here. I want to do it as a percent. So if I put percent, and I add 1 decimal place. And then if I take the average of that, average equals average of all this stuff, it tells me I'm off by 6%, 28 point. This is the number of units I'm off in my sales. This is the percentage, and this is MAPE. What does MAPE stand for? MAPE. It's mean absolute percent error. Justify that. What color should we make this one? I don't know. Let's make it an orangish color. Okay, just the color doesn't matter. I'm just trying to differentiate the two. These are my forecast accuracy. I'm doing the accuracy on historical data, right? Right now, here is now. I'm at the end of month 10. I'm trying to forecast month 11. My forecast using a 3-month moving average is 4.79. Now I want to take the square error, so I say equals, where's the square? Where's the absolute error? Right there. And then what do? I raise it to the second power, and I get 205. And again, I only want one decimal place. Okay, and I copy this all the way down. Yay. So if I take the average now of this, and that's not good, I'm just going to copy these two cells, put them here, and I'm not going to call it MAD anymore, it's MSE. And what color should we make that? I don't know. Want to make it a pinkish color? That's too close to the beige I got right next to it. So let's make it yellow. Let's make this actually orange. And then we have green. Okay. Now the question is, can I live with this? And maybe I want to put commas. So I go up in the formatting, put a comma, and still take it back down to one decimal place. Notice everything in a column is the same number of decimal places. So what I was supposed to do at first was to graph the sales and the month and to just look at it. I did not do that this time. I'll make sure I do it next time. And I want to say insert which is right there. And I want to go to recommended charts. And do I want histograms or do I want the line charts? I want the line charts. Now, one thing I didn't do in class because I didn't have time, I would go here. Now, once I got the chart up and I've got this quick layout, I would pick some option. I mean, there's many options. I could use an option like this that actually puts the numbers on the bottom. If I want, it gives me my month. Or I could pick an option where I do something like this. No, I don't like that one at all. Which one do I like? I want charts, titles on the top and bottom. That's not good either. Maybe I should just leave it where it was. Okay, so what is this? I put a title in there. It's moving average, 2-month moving average, 2-month moving average. Units versus month. When I do it that way, the units are the y-axis, which is those numbers there, and sales, the x-axis is the months. Units versus month. If I want to highlight this axis and I want to make a change, I just double click on it, and maybe I want it to go from 300 instead of from 0. Does that show more variation? If that helps you, do that. If you want to leave it at 0, leave it at 0. The problem with making it show a lot of variation is if you have lots of graphs and you're going to use different scales on all of them, you might want to be a little careful with that. Just saying. Okay, so this is it. We finished this. We are all done here. Let's say I wanted to do 2-month moving average. Well, maybe I'll come here and see maybe 2-month moving average is better. Why don't I just copy that and paste it down here? And I'll copy this. See, once you do it, you can like manipulate it. And let's call it a 2-month moving average this time. Well, everything is going to be the same, kinda, except what's going to happen. I'm going to not be able to use this data, right? I want to say unshade that now, no fill. Because now I can do a 2-month average here. And these are still 3-month averages. It brings everything down. Like right here it says it's the average from C4 to C6. C4 to C6 is there. But if you just want to highlight this and just click on in the window here, it will show you what it's taking the average of. And if you do the same thing here, it was taking the average of those 3. But we don't want 3 anymore. We want 2. So I'm going to say equals average. And in this case, now I want to just take these 2. And what do I want to do? I want to copy that all the way down. So it changed my forecast from 479 to 465. This should be more responsive to the ups and downs. So ignore error. Just leave it alone. And maybe I need to copy these up. These won't change. I don't have to recalculate them. I just have to make sure that I include, 8 numbers instead of only the 7 that we had before. So if I go here to the MAD, it's 28.6, and I click on that. Oh, see, it says it's only going from 26.5 to here. Let's just bring it up one. It does it automatically. Now it goes from E22, which is what I want, down to E29. And I hit enter. And it changes it from 28.5 MAD to 25. It brings it down. So it's a more accurate forecast. I'll do the same thing here. And you can stop it and rewind it and say, what the heck was he doing? And hit enter there. And my MAPE is now 5.4. And if I go here and do the same thing, I can bring that up 1. Boom. I've got it. Isn't that wonderful? Should I graph it again and see if I can see any difference in the graph? So let's say insert. I go to my recommended chart and I pick the same one. I want to be consistent. And what do I want? I also want to make this to 300 since I made the other one to 300. Okay, can I see any difference in these 2 graphs? Does it show any different? I guess it's maybe a little bit more responsive, but it's still, it's a picture, and this is what, 2 months moving average. How did I write it here? I actually spelled it all out. Not average, average. Units versus month. Okay, so that's it. I'm done with this. So I have something. I can put either the graphs or the tables or both into PowerPoints, and if I'm presenting to people, it's clear what I'm doing and not doing. I will post this cleaner, better file in the where will I post it? In Canvas. So let's copy all this. Copy. Now I'm going to go to the exponential smoothing, and since I've done a lot of work already, I don't want to replace everything. But for moving average, I'm only going to do 1. So I'm going to get rid of, I want to get rid of this rows. So all I'm going to do is keep the top one. And how does moving average work? Well, the forecast is going to change, right? Basically, the forecast here is going to change. We'll get rid of that. These are still going to be the same. And we're going to unshade everything here, because we're going to use the whole shebang. Even though here I have to put a seed. Let's see, what do we use? 465 in a class. Let's use 455 this time, and you'll see it's not going to make that much difference. And I make it red because it's not a calculated forecast. By saying it's a seed, I have to do any forecast, I have to use the previous month's sales and the previous month's forecast. And this is now exponential smoothing. And what we want to do is say alpha equals, and what do we want to make alpha equal? We can put any number. I'm doing it this way because if I was going to hardwire it in, I could calculate it. Let's make it 0.4. So I can be clear here. I do the actual times alpha and 1 minus the actual times the previous forecast. So here I am in month 2. I want to say this is going to be equal to alpha right there times, which is the asterisk, the actual. Then I want to add to that parentheses 1 minus alpha times the forecast. Boom, I put that in there. Now, I would like to drag it down, but the problem is every time I drag it down, if I drag it down 1, it actually gives me the same number. Why, I don't know. Let's see what it does here. Here it says I'm using alpha, and I'm using these 2 numbers to calculate it. Now, if I go down here, what is it using? It's using the next 2, which I want, but it's moving this. It's not using alpha anymore. It cycles everything down. So I have to tell Excel to do what? Hold the alpha. So I'm going to put a dollar sign between the E and the 1. And that means if I scroll it down a row, it does not index to the next cell below it. And then I have to do that in the 1 minus alpha too. So let me put a dollar sign there. And if I put a dollar sign before the letter at the beginning, I can scroll left to right and it's not going to change the value of the number. If I never want it to change ever, no matter how I use it, put a dollar sign E, comma 1. Some people just do that all the time to make it easier for them, I guess. So now it changes it to 457, and if I scroll it down, what do we get? That was the right number. And notice how it keeps getting more and more decimal places. Do we like that? No. Let's make it 1 decimal place again. Why 1 decimal place? Why am I obsessed with this? It looks neater. It's what people do. Now it calculated all the numbers. Yay. But my math is still off because if I scroll it, remember we were only doing it to 3, so I want to bring it all the way up here. Boom. I'm going to bring this up here. I'm going to check this and grab that corner and drag it up. So Excel makes things fast and easy to do. But if you had to do this 10,000 times, okay, so it's not 2-month moving average anymore. What is it? Exponential smoothing. We probably should put the alpha in there, but we're going to change the alpha all the time. All right, so let's look at, we had alpha at 0.4. Let's look, let's only figure on MAPE. 5.3, what was it before? It was 6, and this was 5.4. So it's really, it's the better than either one of these 2 already. Most people never use moving average. They would use exponential smoothing because you can dial it in. You can change the alpha to what you want. Let's make alpha equal to 0. What does that do? That didn't change our graph at all, did it? Why? Oh, because it's probably still the graph from the previous thing. That's why. Let's get rid of that graph and make a new one. Notice when I go to alpha equals 0, it's always the previous forecast. So let's put this in here. Let's insert a graphic. There we go. Does that look good? I don't know. It's MAPE at 5.6. That doesn't seem to change ever. Let's make it alpha of 1. Now you can see how instead of a line, it's the previous actual. 460, 415, 432. And this gives us, but it gives us a higher. It goes up to 6.5. So let's start at 0 and go 0.1. And just go up by tenths. 5.5, 5.4, 0.3 is 5.2, that's better. 0.4 is 5.3, so I think 0.3 was probably the best. At 5.2, let's try 0.5. No, it seems to be going up. 0.5, 0.6. Yeah, I think the best one's going to be 5.3 at 0.3. Okay, and this is moving exponential smoothing. Alpha equals 0.3 units versus months. Okay? If I want to make my graph, if I want to make it to 300 since it's the same data set, we can do that. So again, when alpha is 1, it flattens out everything. I mean, it follows 0. Let's start with 0. 0, it is a previous actual. It is the same graph, just moved over to the right one, the forecast. If I go to 0.1, if I go to 0, gee whiz, it gives me a flat line. If I go to 0.1, it starts to follow the ups and downs a little bit, sorry. If I go to 0.2, it starts to follow the curvature a little bit better. 0.3, a little bit more. 0.4, a little bit more. It doesn't mean it's more accurate, but you can see it's trying to adhere to the curve. 0.5, 0.7. I'm going up by 2s now. Oops, sorry. I didn't do it in the right spot. 0.7. And this is what a computer would kind of do. It'd go through all these and give you an alpha maybe to 3 decimal places. That's the most accurate one on the historical data. And 0.9. Oh, I got 2 points. That's not good. It doesn't like that. And then 1 is just the shift. So 0.3 was our best. Let's go back to that. 0.3. A MAD of 24.5 units, that's 5.2%. Great, we did wonderful. Let me copy this one and put it in a simple linear regression. Why didn't it like that? I must not have copied this. Copy. Paste. Make it bigger so you can see it. And let's get rid of this. We gotta get rid of the graph too. Now we're gonna do simple linear regression. There's no alpha, there's nothing. There's no seed. We get rid of the color, make it automatic, and we're going to actually determine what these are. Okay. I'm leaving my ABS, all those things the same. Once I put the forecast in there, it will calculate all the errors automatically on the same data set. Isn't that nice? So what I want to do here is graph the known entity. What's the known entity? I say insert chart, and it doesn't give me a scatter diagram at all. Let's go with this one. And it gives me sales as a function of months. And what I want to do now is get my line in there. The easiest way to do it, once I, let's get rid of the chart. Let me do undo. All right. Oops, it didn't like that. I want to do two undos. I highlight. It always assumes that the X is the first column and the Y is the second column. If you're doing multiple linear, it assumes all the rightmost column is the Y data, and all the columns to the left of that are various X1, X2, X3. If you're going to have more than one variable, we're doing simple. We only have one X, one Y. We're trying to use the month to predict the sale. Okay, so I go insert, and I go to my graph here, yes, and bring it up. Now I go to this quick layout. I go to the one that has FX. When I do that, it gives me my regression equation. Also gives me something called R squared. What's R squared? It's the coefficient of determination. What? What is that? So this is sales by month, or versus. Maybe by month is better than saying it. And here I'm going to put unit sales. And here I'm going to put month. Now this is a well-labeled graph. I mean, it's nothing that exciting. I'm going to leave it kind of like this. All right? If I want, I can rescale it, but I'm going to just leave it like that. You see the dotted line? It is a line. So this is my slope, 5.5818. 436.2 is a y-intercept. So if I want to do a forecast, I'm forecasting on 5.5, which is the slope, m. What's my x? Well, my x is going to be the month. I'm going to multiply that by that one, and I'm going to add what to it? 436.2. I'd put the full numbers in there, but let it come out to one decimal place. Now I'll bring this down. And it's still giving me 496, but what I can do here also, I can forecast much more into the future. I probably should have indexed that automatically, but I didn't. So I can forecast out into the future as much as I want. This is very nice. What's the difference between each one of these? It's 5.5818. To go from here to there, I'm adding 5.5818. To go from this number 2, let me make it even bigger. From this 447 to there, I add 5.5818. To go from there to there, I'm adding 5.51.8. Good news is it will continue as a line forever, as long as I want to extrapolate out. Extrapolate out is beyond the known data. The known data is here, the first 10. So anything after that is called an extrapolation, and it will keep going up by 5.5818 units. Every month you're going to sell more. Is that realistic? Well, it seems to work okay for this. I'm getting a MAPE of 4.6. What's my other best MAPE I had? Was 5.2. We can make that bigger too, sorry. And what was it the first time? The best MAPE I had my 2-month was 5.4 and 6. So by far, in this case, simple linear regression is probably the way to go. But all sales are not going to go up 5.5 in perpetuity. It's just not going to happen. So if you can do this, if you can do moving average for X number of months, or if you can do exponential smoothing, or if you can do simple linear regression watching this video, you're ahead of the game, which is pretty cool. You can do most of the homework problems. Let's look at what the homework problems are. I should have had that file already up. I'm sorry that I don't. So let's go to Canvas. I'm going to go back here, and I'm going to go to week 3, forecasting worksheet. I'm going to open up the Excel version, okay? And when I open it up, that didn't do very well. I'm going to download it so I can open it up. There we go. Of course, it opens up the Word document. Let me open up the Excel. I'd rather have you do it in Excel if you can. I don't need this. What do I want to open up? I want to open up the Excel. I downloaded the Word document. You can tell I rehearsed this beautifully, right? Okay. So here's the homework. 1, 2, 3, 4 problems. The first one, I give you the forecast, I give you the sales. Oh my God, the columns are backwards from what I did on this one. I had the actual, then I had the forecast. But it wants you to calculate the MAD, the MAPE, the MSE. So how would you do that? MAD, the MAPE, the MSE, where's that? Right. No, that's not there. Where's my file? Did I close it? Oh, there it is. I've got to put absolute error. I've got to put absolute percent error. MSE, I taught you, I just showed you how to do that. Go back and look at it if you forgot. See how to do it. Do it. There's some templates I have that actually could fill all this out for you, but I think it's better. You'll really learn it if you actually have to at least make Excel bow to what you're trying to do. So all I want to do is look at forecast accuracy. What is the number 2 part? Here's this company, the French Widget Company, reported annual sales in millions of euros in a table below. It's a full year's worth of data. Create a simple linear regression model using the simple graphical method we taught in class. Comment on the accuracy of the model using the visual, the R-squared, and if so motivated, MAPE. Really only use MAPE. I think that's the best one to use. So what is this R squared? It's the coefficient of determination, which doesn't really help you anymore. But as a percentage, it's 0.2952. It's always going to be a number between 0 and 1. If you look at it as a percentage, it is the variation, the percent of the variation of the Y data, in this case, unit sales explained by this model. So I'm predicting 29% of the variation in the Y data using this linear regression model. Does it look like a good fit? It looks like a good fit. It has a nice R squared. It has a nice MAPE. I could use this as a forecasting model. Will it always work? Well, it will work until something happens and makes sales jump up faster or makes sales start to go down. Then a regression model is not good. The Holt-Winters method, which we didn't talk about, combines regression and exponential smoothing to follow these undulations. And then it has a seasonality factor too, which kind of does the best of all. It gives you some exponential smoothing for the trend. It gives you a big trend using regression, but it uses exponential smoothing to adjust that trend if it starts to go the other way too, and it gives you seasonality. All right. R squared, again, is the percent of error in the Y data, in this case, unit sales, that is explained by the model. So let's go back to the homework. So this is simple linear regression. Okay, here's one. I've even given you the table, and we're using MAD. That's all it wants you to do. I want you to use 2-month moving average and exponential smoothing with alpha equal 0.4 on this data. It all looks like the same. Is it the same data I'm using here? Gee, that would be bad. Oh, darn. That's not a good thing. I'm using the exact same data. Oops. Well, maybe I won't post this. But you should do it yourself. You can see the answers here. Well planned out, Professor Gavoor. And then what's the last one? Ooh, if a manager asks you whether to use time series forecasting models, which is moving average and exponential smoothing, or regression-based forecasting models, what would you tell him or her? Well, I'll tell you right now, kind of the answer to that, but an advantage of regression is that it can forecast as far out into the future as you want. The negative for regression is it commits you to either a line that has a positive slope, which means every month you're going to go up by whatever the slope is, or if it has a negative slope, every month you're going to go down by whatever the slope is, the same unit every month. That's not realistic long term, might be good short term. What's the advantage of exponential smoothing and moving average? The time series approach is that it kind of follows the undulations of the data. What do I mean by that? This is a straight line. The data undulates, it just does this. But look at the exponential smoothing version. If I make it like the exponential smoothing version, if I make it 1, it's just a copy of the data slid over 1. So it's trailing behind what's actually happening, because I'm using the previous actual as my next forecast. So you want to find some mix of flat, which is 0.0, which is using only the forecast, which doesn't follow the ups and downs at all. And we decided a 30% is the alpha to use for this. And it gives us something like this, and it gives us the best mate. So the advantage of exponential smoothing moving average is it follows the curves in the data better than regression does. The negative is it only can forecast one period into the future because it's requiring the actual to be there. And it's not there until a month happens. So that's the plus and minuses. All right. Hopefully this works. I use a data set that you have to do. So I've actually done your problem for you. You're working together. I would still just, what the heck? You can copy and paste it and get a good grade. Yay. Did you learn anything? No. Go here and try to fill out the form. Each one. Try to do it from scratch. Because if you only have to do like one row and then copy it all the way down and then take the average here and take the average here and you're done. Regression, I left it like this. I didn't give you anything. This is a different data set, still in the same 400 or 500 range. But if you want to do something different, take this data and do 2-week moving average and exponential smoothing using whatever. And if you do this right, you can change the alpha and see what you get. So this, I leave you got to write an answer here. So you must type your answers. Here. Use full sentences. Use capitals, punctuation. Don't be afraid. This is something you want pretend your boss's boss is going to see. All right, I think I'm done. And I'll see you guys next time.